Solving equations by factoring. So all of the things that we've been using to factor, we are going to use today, and then just one quick step, solve the actual equation. So we'll look at that. The first thing I want to say is if you have two things multiplied together, any two things, and it equals 0. So actually, let's write this down. If you have two things
Good morning, teachers.
So if you have two things multiplied together, and you already know it equals 0, i.e. A times B equals 0. If you have something like this, then these two things, one of them has to be 0. The only way I can get 0 is if I multiply 0 to something. So like if A was not 0, then the only way I can have this equation be true at the end is so that B is 0. B has to be. So the whole point of what we're doing today is we're going to write our equations. They will have an equal sign. That's different from what we had before. And we're going to hopefully factor it so that it's two things multiplied together. For the equation to be true, either the first part has to equal 0 or the second part has to equal 0.
Good morning.
So what I want to say after this is if you have two things multiplied together and it equals 0, something like this, then either A must be 0 or B must be 0. There's no other way to end up with a 0 on the other side unless one of them are 0. So that's called the zero product property. Half of it's in red, half of it's in pink. So, what the heck is the point of all of this? What I'm saying is we're going to use this idea to solve an equation after we've factored it. So, for example, 1. Solve the equation by factoring. Negative 3x squared minus 9x equals 0. Notice the right side is 0. So there's steps for this, but hopefully with this zero product property that we had, hopefully it makes sense why we're doing these steps. But the first thing is always going to be try to factor out a GCF. Sometimes it'll work, sometimes it won't. Factor out a GCF. In this case, it does, and you can divide by negative 3x. Whatever you divide by goes on the outside of the parentheses, same things that we've been doing before. Then we get just regular x plus 3. And then don't forget to bring down the 0 and the equal sign. But now I have multiplication. Two things multiplied together, just like I had here. So if this is going to equal 0, meaning this equation, it's going to equal 0, either this has to be 0 or this piece has to be 0. So then the question that, bless you again. The question that you can think of is, what makes this part equal 0? And what x value would make that equal 0? Yeah, 0. You plug in 0 for x, then negative 3 times 0 is 0. So I guess the answer is x equals 0. And then same question on this piece. What makes this 0? Answer. If I plugged in something, what makes this 0?
0.
No, if I plug in 0 here, 0 plus 3 would be 3. That's not equal to 0. Negative 3, right? So x equals negative 3. So our two answers are x equals 0, x equals negative 3. And if you were to plug in 0 to the original, well, negative 3 times 0 squared is 0, minus 9 times 0 is 0, so you get equals 0. Or if you plug in negative 3 to this, it should also equal 0. So I'm going to check that part real quick just so you can see. Negative 3, so this is me checking. Negative 3 times negative 3 squared minus 9 times negative 3. Let's see if this equals 0, because it's supposed to. So negative 3 squared is 9. Negative 9 times negative 3 is positive 27. And we get negative 27 plus 27, and that is 0. That's what we wanted. So the steps were to factor, and then once you have it factored and written as a product, then the second step, well, I guess here we factored it at GCF. Factor further if possible. And then the third step was to do this part. But I think maybe you'll remember this. Some people say just set each piece, or set each part equal to 0. These will go by a lot quicker once we get going. So we have same instructions. Solve the equation by factoring. 2x squared plus 3x minus 27. First step is to divide by GCF if we can. And I can't divide either of these by 2, and that's the smallest number there. So, can't factor with GCF, but I can do the x factor. So what would that be? 2 times negative 27. What is that? 54? Negative 54. So a times c in the top, and then 3 in the bottom. Is it 9? Yeah, 9 and 6. Thank you. One of them has to be negative, and it should be the 6, because if I add these, then I'll get a positive 3. And we have to divide by this 2 and an x for using super x. And reduce. I can't do anything to this one, so I'm going to have 2x plus 9. And then this one I can divide by 2. So that would be negative 3 over x. So x minus 3. And then that equals 0. In your head, you can think, what x value makes this 0? And what x value makes this 0? This one's easy. It's just the opposite, x equals 3. But I'm going to just show this. You could set each piece equal to 0 and solve separately. That will tell you the answer to the question for what makes it 0. So then I can solve this. Minus 9, 2x equals negative 9. X equals negative 9 over 2. And then plus 3, x equals 3. Those are our answers. If you were to change this or plug it in here, you should still get 0 once you added them all up if you're using PEMDAS correctly. So all of the factoring that we've been doing, we can do with this. The only new steps are to set each piece equal to 0 at the end because of the zero product property.